Mallory. Nice of you to show up today. We missed you. I just said good morning to everybody. Did I miss somebody? I missed you, Skunkster. Good morning. Good morning. Good morning, Ava. Did I? Or I did. All right. Don't leave anybody out. If I did, I apologize. So today we are going to do a new topic. Make a new topic. All right, I thought we're done. I skipped 2 integration techniques in our. Nice of you to show up. Those are from yesterday. Sit down. Good morning.
Morning, how are you?
It's no fun being a public right? I'm kidding. All right. So I skipped 2 integration techniques for 2 reasons. One is because that unit was getting long, and I think it tested it in one day. And the other is because it's something that requires memorization, and that I tend to have to redo again. So we're going to cover a new integration technique today. After doing the warm-ups, you should be keeping those on separate sheet of paper in the back of your binder. Distance learners, just keep them like sequential in a notebook, because I will eventually be giving points for them. It's a full practice exam. It's just going to take us probably till the Friday before your AP test before it's done. So I can't put a number on it. It might be like number 41 or something by that time. So you guys in here, just keep it in the back. At home, just keep it in a notebook somewhere, and I'll eventually have you just sort of scan through it. All right, so we are going to do notes on inverse trig antiderivative rules. So we're going to be integrating today. Distance learners, you'll be taking video notes. Homework is 18 through 20. It covers today, tomorrow. There's video help for it, because last year they were full distance learning for this, so they could ask me questions. And then also, because I won't be seeing you seniors for a while, the juniors, you'll be with me Monday and Tuesday. My room's a testing room for MCA, and then I'll have juniors from some other classes. Seniors, you're to go to Mr. Michener's room on Monday. Not a big deal if you come here first, but I'll just send you to Mr. Michener's. There is still work. It's still a class today, but you'll be doing that over in his room, okay? So any questions? Good morning. Who else just walked in? Good morning. Nice of you two to show up. I just said it. I say it to all of you. It is nice, but I always say it. All right, so what are we going to do? I want you to actually hop on, and we're going to do some warm-ups, which is a full practice exam that we're kind of just piecing together, because if I had you take the whole thing in class, it would take the whole week. Because it's just based on time. They're 3.5-hour long tests. We're on number 6. So number 6 involves, I hope that spinning wheel, thank God. All right, they had the spinning wheel again. All right, so anyways, we are measuring the rate in which people per minute are passing through a security station in an airport. So this is the rate. This is already a derivative. Using a trapezoidal sum with 3 subintervals. So I'm going to be using all 3 of these. Watch this though, because sometimes we'll say in the first 40 minutes with 2 subintervals. So make sure you read the entire stem of the problem. We need to do a trapezoidal sum to figure out the number of people per minute, or just number of people. Because when we multiply people per minute times minutes, we get peaks. We have to remember our left, our right, our midpoint, and our trapezoidal. The trapezoidal is the hardest, which is the reason I chose this. I want to make sure we're practicing a little harder. But remember, if it was left rectangular, we would do 10 times 5 plus 30 times 4. We stick to the left, right? Any correct? All right. Who remembers what you do for the trapezoidal? That's the hardest one to remember. Let's pick on Chuck. Oh, yes. 1/2 times all of that? Oh, times the quantity. The interval, so just doing, this would be the height, right, of the first trapezoid. left base plus right base. Yes, you got it. That right there represents the area of trapezoid number 1. Half of the height can be sum of the bases. So if you forgot that, sketch it out. Make a straight graph and see it's the trapezoid, but that's a time sucker upper. Is that a word? So then let's go have you guys set up the second trapezoid. And then it becomes arithmetic, and I'm not going to, maybe if I could have one person crank it, I better have 2. Let's do the late people. Clocker, Tucker, Sammy. Now we're hardly late, so I'll leave her out of it. You 3 are going to have to calculate it out. That's the punishment. All right, so the next one, so write them all out. Just make sure you wrote the next one out right. He already pulled the half out front. So just do the half the height, sum of the bases, plus a half of the height. 30. Sum of the bases, left plus right. And then there'll be the third one. Half of the height, sum of the bases, left plus right. You 3, calculate it out. Without calculating. Not calculate it out. Got it? You got 185. And you need a Tucker, you did it already. Thank you. 185 people using a trapezoidal sum. Amazing. What is the total area of the regions bound by the curves? And remember, you don't have a calculator. So this one, what I'm going to do is graph the line first. Y equals 3x. It's going like this. Going through 0, 0, 1, 3, 2, 6, and you might want to get a couple points on there, but there's my line Y equals 3x. The other one, you do need to be able to sketch it so that you can determine top function, bottom function, and limit. So you should know it's a parabola that opens up or down. What do you think? Right? So the parabola, it opens up because of this lead, right? What's the most important part of the parabola? That's exactly what my main students are doing in exponential algebra right now. They're graphing parabolas, and I tell them you have to have the, what? Vertex. Now, there's a couple ways to get that. You can use negative b over 2a. Remember that. I actually think it's safer just to find the zeros and the vertexes right between them. I just, I'm not playing all this. 2x minus 3. So the zeros are at 0 and at 1.5. The vertex is always right in between the two zeros. And I know it opens up, so I think that's a little faster. I don't really care how far down it gets. Here's the problem. They told me to integrate from 1 to 4, but I can't do this with one integral. You remember why, Kalia? Why can't I just set up one integral from 1 to 4? They do, they intersect, and at that intersection, the top and bottom functions swap out. This is one, if it were on the AP exam, I would start it and go, I'm going to come back to this one. This takes a lot of time. You come back to it at the end. You don't have to do them sequentially. So even if you know how to do it, I'd say, I'm going to move on. This is one I'm going to come back to if I have 18 minutes left at the end of my time. Does that make sense? So that takes a while. So we would integrate from 0 to the intersection. I wouldn't set them equal because that's a time sucker upper. I would guesstimate, and then if it doesn't work, where do I think they probably intersect? Just based on my crappy graph, 2. How do I check that out? I go 24 minus 18 is 6, and that's 6. So I'm 100% sure, so I don't really have to do the algebra. They're going to be at a nice spot, like 1, 2, 3, 4, because you don't have a calculator. So I'm going to integrate from 0 to 2. Top function, which would be the line, minus bottom function, which is the curve. Notice this is going to take a while because you don't have a calculator. Right? So honestly, I would skip this one, even if you know how to do it. And then I would go from 2 to 4 and swap these out because then the curve's on the top. I'm not going to finish that one because, like I said, it's a time sucker on curve. But if you know how to set it up, it's just going to go all arithmetic and you're going to get crabby with it. Right, Annika? All right, so I don't know what the answer is. Answers are always what I'm concerned with. We're going to go to number 8. A function f is defined by, well, it's a parabola. I'm just going to go make a fake parabola. It opens up, yep, it leads with a positive. Just make a fake parabola. It's good to get a visual, right? Seriously? Like, I want to see what's going on. If the line tangent to the graph at -2, so let's go do that. Line tangent to the graph, so this is my situation, is parallel to the line 2x plus 3. And you might say, well, that can't be because yours is going downhill and that up. It doesn't matter because I just need a fake graph. I just want to understand what has to happen if lines are parallel. What happens when lines are parallel? Algebra 1 and 2. They're what? They're equal. Slope. What's the slope of this line right here that I'm running parallel to? 2. So the slope of this one has to be 2. What's the slope of the tangent line called in calculus? The derivative. So my derivative, 2x plus k, the slope of my tangent line has to be 2 because they're running parallel. At x equals -2. So at x equals -2, the only value of k that'll force those slopes to be equal is k equals 6. All right, so this is one where I just kind of read it and write down what you know. We're going to move on to the next one. We've got f of x equals, remember f of x is y. I always like to get a sketch if I can. I'm hoping you know y equals x looks like this, but it's only for x less than 0. And then y equals 2 runs like this. I'm supposed to integrate from -4 to 2. You can do this 2 ways, and I'm going to do it both ways. You can do it with geometry, right? What's the area of this? Because that's what that means, the signed area under the curve. What's the area of this right here? Go ahead, tell me. Go ahead, Will. 4. So 2 by 2. You might say, I don't want to graph it. Then don't. I'll show you the other way you can do it. But it's so easy to graph because those are such basic functions. They're just lines. And then over here at -4, again, it's line y equals x. I have a 4 by 4 triangle. Base times height divided by 2 is 8. But it's under. So what's the answer? -4. Now suppose Lucas is like, not a fan of that method. I say, well then you need to integrate from -4 to 0 x. Then you need to integrate from 0 to 2, 2. You have to split it because it's a piecewise function and those get split. Does that make sense? So Ava, what I do is just take an antiderivative from -4 to 0. Watch when I do that. Okay, so I'm going from -4 to 0 under the x plus 2x from 0 to 2. So when I do that, I'm going to get 0 minus 16 halves, 8, plus 4 minus 0. Did you not get the same answer? Which one was smoother, do you think? Which one did you choose? Left or right? He's right, he's right. Which one did you choose? Right or right? I would choose the left. So who else would choose the left? I would choose it just because of my own learning style. But if these were uglier functions, then go to the right. But they're so nice. They were so nice to graph them. I'm just going to look and see what it looks like. All right, we're on number 10. I think we'll only go through number 10 today. I have other stuff I need to do. Let f be a continuous function. Ooh, U sub. Do you remember I told you that you don't have to change the limits, but you have to know that you know how to change the limits. I said they'll leave one under base to make sure I've taught you guys how to change limits when you do U sub. Right away, I know this one is out. Because if this is U, right, du is -2 dx. What kind of a fraction correction do I need? Negative what? 1/2. So this is out as well. I'm going to say, I'm going to save myself some time. Somebody think ahead and know why I'm just crossing that one off. What did G neglect to do on this? Yeah, I'm not even going to go to it because you see what I mean about time thinking technique. I'm not even going to go finish it. I know might be no limit change, one of these. Oh, it must be a fraction correction. You see how fast that one could be done? Almost in your head, actually. All right, we're going to quit there. Okay, so I'm going to star that, and I'm going to have, there's somewhere where it says pick up from number 12. We'll be picking up from number 11. All right, so next up, I'm going to stop recording because I recorded this already for